So first of all, I'd like to remind you that yesterday was the International Teachers' Day, and I'm pretty sure that every one of you has someone who helped them upskill. So let's first give some applause for all the teachers that helped us upskill in the past. Thank you. Secondly, this is in the past 3 years the first Voxed events in person, so I'm pretty sure that most of you came here to have fun. So let's have a selfie together, okay? And we will say Cluj, okay? So 3, 2, 1, hands up and Cluj. Cluj! Okay, thank you very much, guys. Are you awake now? Cool, because we are going to discuss a very important subject, and I only have 50 minutes. Spring Security New Authorization Server. It's a new piece of component that will be released in November, and I'm pretty sure that all of you using Spring here, you are looking forward for November. Who is working with Spring and Spring Boot here? Quite a lot of people, which is what I expected, of course, because otherwise you would probably not have attended this presentation. And do you know why are we waiting for November, which is somewhere between Halloween and Christmas? What event, important event, is between Halloween and Christmas? Release of Spring Boot 3, okay? We'll see how it ends up. But it's not only the release of Spring Boot 3, it's also the release of the real first version of the new authorization server, and the whole community has been waiting for this moment. Because about a couple of years ago, we lost a very important piece of the Spring ecosystem. That's the possibility to create an OAuth 2 authorization server. When the Spring Security OAuth project has been deprecated, the part that is related to the resource server and the client and the login has been moved to the Spring Security dependency. But we lost something. We lost the authorization server. There was no way to create an authorization server with something in Spring without using a deprecated library. And this is why our discussion today is very important, because we'll discuss about the release of the replacement for writing an authorization server. Is the new framework that allows you to create your own authorization server with something from the Spring ecosystem and avoiding using some third parties such as Keycloak, for example. Not that Keycloak is bad, but sometimes we don't want to use third parties and we need to create our own pieces of software that act as an authorization server, and now we'll be able to do that with a really aligned library with the whole Spring ecosystem. That's why it's version 1, that's why it's important. It's our new hope. Let's hope it will not end as a 1977 movie in the end. Science fiction movie. A couple of self-marketing. Most people know me for my books and for my YouTube channel, so guys, if you don't already follow me, please do that. You will find a lot of excellent information. The second book, Spring Start Here, I also have here 3 copies with me, and I will share them with some lucky guys, some lucky of you folks at the end of the presentation. And I'm happy to tell you that very soon my 3rd book will be released. You can already order it, pre-order it, and it will be printed in about a couple of months from now on. Now it's in copy editing. A book on troubleshooting Java applications. With that being said, let's discuss the topic for today. Spring Security, the new authorization server, some links for you. I will share the presentation at the end on social media, so you can take a picture now if you want, but you will also have the presentation at the end. There are the 2 most important links from my perspective related to this project. Here is where you go if you want to learn something more than what I will be able to share with you today. But my plan for today is to tell you, to show you how easy it is to actually implement an authorization server, and the fact that the way it was implemented, the architectural decision was such in a way taken such that it makes everything pluggable, which is very essential for both extensibility and testability. Now, until now, we had only versions 0 point something, and these versions, even though theoretically The first 0. version, it was 0.2 version that was already available for production. It was not aligned with all the Spring ecosystem. The fact that in November we will have version 1 is exactly what says there, and you don't have to you don't have to read it, but what it says there is that it will be aligned from version 1, which is from November this year, with the whole Spring ecosystem. And that's why today we will actually use version 1, which is milestone 2 at the moment, and we will use it together with Spring Boot 3. So that's what I planned for you for today. Before trying it, let's see exactly what our demonstration will be about. It's implementing the most essential grant type from OAuth 2, which is the authorization code grant type. Okay, we will implement an authorization server that is able to deliver in the end a token using the authorization code grant type. And to remind you how the authorization code grant type looks like, is that way of getting a token where the user, that's not Darth Vader, it's a user. I think in my book his name is Katushka or something like that. The user wants to get some information. The client needs to gather them from the resource server, which is actually the backend, and in order to do that, it needs to get a token, an access token. So that's what we are going to prove, that we can get an access token. And to get an access token, it's redirected to a login page, logs in, and then is redirected back, and basically that's mostly it. Will we be able to do that? Hopefully, if our live coding gods allow us today, and the internet connection here in the hotel. Now, a few of the things, there are basically 4 main things that we will implement to be able to do that. These 4 are the components that we will have to plug into our security configuration for our application. The first one, provider settings, is renamed, that was the name up to version 0.3.0. It's renamed now to authorization server settings, but I kept on my slide the old name for the purpose of telling you that it will be renamed. And that is the place where we theoretically configure all the settings related to the whole application. We will use, however, only the basics out of it. We will not go into too many details. Being an authorization server, it needs to deal with users. So same as any Spring Security applications that has to deal with users, we will need to implement a user detail service and plug it into our authorization server. And because it's an authorization server, it also has to know its clients. The clients are the applications that want to obtain an access token in order to be able then to get the access a resource on the backend side. So we will have to implement also a register client repository, which is the component in the authorization server that will allow us to manage the client details information. So the user detail service, which is the old Spring Security contract, allows us managing the user details. The register client repository allows us manage the client details. And the last component we need to plug in is key source, which is basically the component managing the keys used to sign a token. Because if you remember, a JWT token looks like this, and it has a header, a body, but also the third part is the signature. And the signature is very important. The signature is the way in which the resource server, meaning the backend side, validates that the token hasn't been altered in its way. So if we wouldn't have a signature, then we wouldn't be sure that the token is secure, that no one changed something inside. And to be able to sign a token, we need a pair of public-private keys, and we will have to plug in a JWK source to let our authorization server generate a couple of keys maybe, and use them to sign the token. But I think we talk too much, and we need to see it in action, otherwise it doesn't really make a lot of sense. So let's create a new project. And VDCLUJ authorization server. We use the latest long-term support in 17. I would like to use milestone 5 of Spring Boot 3 for this demonstration. And then the only thing I really need is the web dependency here. And then I will have to add the Spring Security Authorization Server dependency manually because being it's the first version, it hasn't been yet plugged into the configuration of Spring Boot, the predefined configuration of Spring Boot, so I will not be able to select it from here. So let's create the new project, start it in a new window, say. And I hope the font is big enough to be seen from the back. Let's start with the POM.xml file where you can see that we are indeed using Spring Boot 3. And we can see that we have the starter web dependency. And this is basically where we will add our dependency for the second milestone of the Spring Boot Authorization Server. So this is you guys, but where was it? OK, I will just take it from here. Of course, you find it on Maven Central, but I would not like to spend the time now searching for it. I will spend the time copying it. Oh, come on. No, doesn't want to work. Fine enough. Not this one. This one is ours. OK. And usually I'm refreshing the project. I'm reloading the project to take the dependencies. We will see our application indexing a little bit. And I think we are fortunate enough probably to have the dependency locally, so I don't have to use the hotel's internet connection. With that being said, I should now be able to simply write the configuration. So I'm usually creating a config package for that. And inside the configuration package, I'm just creating a class that I can name security config. Being a configuration class, you have to add the configuration dependency. And because we are using the latest Spring Security version, we are not going to extend Web Security Configurer Adapter, because Web Security Configurer Adapter, which you can see here, is now deprecated. We don't use that anymore. So who was using Web Security Configurer Adapter here for their security configurations? A few of people. OK, you guys, you have to upgrade and remove the Web Security Configurer Adapter. So otherwise, you will use deprecated software in your application. What we will have to use instead is the security filter chain. So the security filter chain is added as a bean. The HTTP security object is now a bean in the context already, so it will just be injected as a parameter of the method if we use the proper annotation. And then we can start our configuration. Now, we will have a couple of security filter chain objects in the context. We'll have to define two, not only one. And I will immediately explain why we need two and not only one, but I will need to make sure that we give them different names. So let's name this one AS security filter chain, meaning authorization server security filter chain. And the second one, copy-paste programming doesn't work for my laptop. It's protected against copy-paste programming. And we have the, let's say, app security filter chain. So this is the couple of beans, and we need to make sure that they are taking the right order. So we will use the order annotation, and we will make sure that the order one is given to the first, the one named authorization server security config, and then the second is the application. And what I will write here is most likely something that in the future you will have in the convention configuration by Spring Boot. So the reason I'm writing 2 now is because there is no way Spring Boot 3 can, at the moment, have a convention configuration on the authorization server because there is no authorization server released yet that is aligned with the Spring ecosystem. So because of that, I will have to manually define the configuration for the moment, but imagine that somewhere in the future, this will directly be put from Spring Boot. So you will not have to write the first bean, but only the second. Now I think it makes sense why I'm writing 2 of them, OK? What do I need to write here is that default configuration, fortunately, is now given by the framework as a static method, so it will be even easier for them to put them in Spring afterwards. So it's name authorization server configuration. And then apply default security. And then we need to, of course, throw the exception. And one more configuration, I need to make sure that if the user is not authenticated, it's redirected to the login page. And I can do that using an exception handling configuration and an authentication entry point. And we already have a login URL authentication entry point. I can use it and specify the path to the login, which is the default one since I didn't configure any other. And the default one is actually login. And then I just build the security filter chain and return it. And that's what you see here. You don't even have to remember, because in the future, you will not have to write it, okay? I have to write it now because I don't have any other choice, but in the future, Spring Boot will most likely already configure this by convention. Now the second one, this is where we define actually the authentication method of the application and the authorization rules. And I will take the simplest possible, which is I will give the user a form login so they can write the credentials. Fine, it's out of the box. And then I will say that all the endpoints are authenticated. So I say authorized request, any request, authenticated, and build. Okay, let's make sure that we throw the exception. And this is everything about the filter chain that we need to configure. Now, going back to our diagram, we need to define the possibility to manage the users, the possibility to manage the clients, a key source, and the provider settings. The provider settings is the simplest, because you just have to say public authorization server settings. And then if we don't want to change anything in the URLs and we want to keep those from the specification, we just say return authorization server settings, builder build, and that's the default. And most likely this bin will also be provided by convention. Now, of course, to manage users, those of you who already use Spring Security, you know that user detail service and password encoder are the two main components used to manage the user details. So let's create a user detail service and the password encoder. And to keep things simple, I will use a password encoder. I will use a no-op password encoder, a password encoder that doesn't change the password, but that's something you shouldn't do in a real-world application, okay? This is only for demonstration purposes. That's why you will see that it's striked out, marked as deprecated, because we use it only for examples, okay? So, public user detail service, which will be a bin. And for our demonstration, should be enough if we use an in-memory implementation. In the latest version, I think we can even give it as a parameter, so we can do like this and say we need the user with username, whichever username we want, password, a very secure one. Authorities, we need at least one authority, even though we'll not use it, it's mandatory. And that's it. So we have a user. If we have a user, we need to be able to manage the password. The password encoder will do that. But we use a plain text password, so I'm using the only demonstration purpose, no password encoder. And I finished the user management. Now, going back to our diagram, we need a registered client repository. This will be the component managing the clients. Yes, in a real-world application, the details for the user and for the clients will most likely be stored in a database. But that's only implementing an interface, isn't it? So it's very easy. What we prove here will work with any implementation of the user detail service and any implementation of the registered client repositories. So let's create our bin of registered client repository. And of course, I will continue using an in-memory implementation, but again, in a real-world application, you can easily implement the interface and give whatever implementation you want to, for example, keep the data in a database or somewhere else. We need a registered client. We'll always need an ID, which is an internal ID. This is not a client ID, it is not its username, so I will just make it a random value because I don't care what it is for the moment being in memory. In the case you keep it in a database, it's most likely that it will be, for example, the primary key or something that you can search from in the database. And then we need its username, and we know the username of the client is called client ID, so let's call it client. We need its password, which we name it a secret, and let's call it secret. And then we need plenty of details. I think maybe the most essential is to tell our authorization server what is the grant type we will use. We said that we will use the authorization server grant type, the authorization code grant type. But you can add multiple grant types if you need to, for example, use the client credentials as well. They deprecated the password grant type, and I think that's everything possible to use for the moment, and at least in version 1. Then we need to specify how the authentication will be done. Now we can use no authentication, but I would recommend you use HTTP basic. So maybe we need a scope. Not only that it supports, not only that the new authorization server framework supports OAuth 2, but it also supports OpenID Connect protocol, which is built on top of OAuth 2. So I will be able to use one of the OpenID Connect scopes. They are even enumerated here, so you can simply just select them. And because we are using the authorization code grant type where the authorization server redirects back with an authorization code to the client, we will need redirect URL registered as well. So HTTP, VDCLUJ, Vox days maybe, and auth, and build. Do I miss anything? I hope not. I think that's it. That's at least the minimum, of course. You can configure the token, you can configure the client, you can configure more things here, but I will just take the minimum I need for my example to work, and this should be the minimum I need. Is it? Yeah, should be the minimum I need. Cool. And then, the most difficult part, the most ugly of the parts, is the key source. Why is it ugly? Because I will have to use Java security. And I'm not sure how many of you worked with Java security, but it's one of those parts of the JDK that is not really clean in general. A little bit more difficult to use. But we will have to. So let's define a JWK source, which is the component managing the keys that will be used to sign the tokens, okay? Security context. And we need to generate a key pair. So we will use the key pair generator. This is not the only way in which you can generate a pair of keys, but in my perspective is the simplest. Of course, we can use some third-party library to make the things easier, but I would not like to introduce some more things in our demonstration now. So let's simply use the JDK, okay? So a key pair generator for your algorithm. We will use RSA. Throw the exception. Let's actually use exception because I think we will have some others as well. Then we define the size of the key by specification 2048. And then we generate the key pair. From the key pair, we take the public and the private key. So I should have something like RSA private key is key pair get private. And because I don't have a really good contract defined, I will have to do something very ugly here. That is, I will have to cast this to RSA private key. And it will work since I used the right algorithm here. But that's one of the reasons I say that Java security is not really, it's one of the parts of the JDK that's not really strongly defined. Hopefully, it will be refactored somewhere in the future. The same we will have to do with the public key. And then we will have to put everything together into a key, put it into a key set, and expose it as a key source. Sounds complicated, but it's not really that complicated. We only have 3 more lines to write here to make it complete. What time is it? OK, I still have time. So RSA key is the key. And the simplest should be using a builder. It needs an ID. Again, let's just create an ID with a unique identifier. And then we need a key set. And the reason we need a key set is because even if here I will only define one key, in a real-world application, you will most likely have more keys, and they will be rotated by the authorization server. So it's not the same key every time used to sign the token. You might have multiple keys in the set, and for each token, the authorization server will rotate the keys and will choose another one to sign. And then we need to return, I think, they created in the last version something called immutable key set, immutable JWT key set. That is a wrapper over the key set. It's actually an adapter over the key set to the key source. So it adapts this object to this interface to make things easy. And it needs to be a bin in the context, otherwise it will not be used by the authorization server. And this is everything. We just created our first authorization server using Spring Boot 3, and we using the second milestone of 1.0.0 of the authorization server, only in a few minutes. Now, let's see if it's also working. Even if it's not working, it's because of me, not because of the authorization server. OK, it started, I guess. 2.8 seconds. And now what we can do, and to make things simple, I will just prepared the URLs. These are the standard URLs, authorize and token. The authorize is the one from the specification, to which you redirect the user so they can log in. And then the token is the one called by the client to get the access token or ID token, depending if we use directly OAuth or OpenID Connect. So let's try them. So I'm just going to copy this one. into the browser. I'm redirected because I'm not signed in. I'm redirected to the login page. I will use my only user, Bill. 1, 2, 3, 4, 5. And then sign. And that's fine. Okay, it's a 404, but it's because I'm using a site that doesn't exist. I'm using that page that doesn't exist. The most important thing is if you look in the browser address bar, you will see that I have been given an authorization code. And this is the authorization code that I can use to get an access token. So the flow works well. Of course, to get the access token, I have to post on the token endpoint. So let's try to post on the token endpoint. I'm taking the token URL. To post it, I'm going to use Postman. Okay. I think this is the one here. And then I will use the correct value of the code that I just been received in the browser. So I'm going to take this value, copy it, put it here, make sure that I use HTTP basic with my client credentials, otherwise it should not work. And then I'm going to just send, and I'm getting an access token, an ID token, and everything else I requested. So this is it. This is a JWT. If we want to inspect it, we can try opening a jwt.io page. And this is the result. You see the key ID is here. This is what a resource server would use to validate that the token is okay, that the signature is fine. And then all the information. The claims can be configured. They are configurable as well. We won't do that now, but they are configurable. So that if you want to add some other information here, you can do that. In practice, you need that in many cases. So that's it. We proved that it works fine. And I still have some time, so I'm going to preview something else as well. I'm opening a terminal. I'm shutting down the application. Actually, let's shut down the application. And let's open a terminal. And we are using Spring Boot 3, aren't we? And Spring Boot 3 comes with something even more interesting, the possibility to natively compile out of the box. So that means that even this authorization server can be natively compiled. And if we would manage to do that, we can prove, hopefully prove, that the startup time will improve from 2.8 seconds, I think it was, at the beginning of the presentation when we started it, to maybe something that is 0. seconds. And it might not look like a big difference because here I didn't use anything in terms of other libraries or dependencies. But remember that in a real-world application, you will use Hibernate, you will use N dependencies here that will increase a lot, even more, up to many seconds, the startup time. So we can say if we manage to decrease from 30 seconds the startup time to 0. seconds, that will be usually the time for a natively compiled application. That's huge for an application that is running in a cloud environment, because it means that the container spins up immediately when you put it in Kubernetes or whatever you use. So we should be able to use Maven and say Maven -p native, because this native profile comes out of the box with Spring 3. I will have to say -d skip tests, not because I don't want to run my unit tests, but because I anyway shouldn't run them natively. So unit tests are not for a native compilation. And then package. And the downside of compiling natively an application is that it takes a lot of time. That is maybe 1 minute in our case. So let's until it hopefully completely builds the native application, take some questions if you have. Please, we have a question there. Microphone? The session is recorded, so it's better if you speak in the microphone.
So you showed us previously the key ID of the public key. How would the resource server then use that key ID to verify?
Excellent question. Excellent. Thank you very much for the question. So I closed the application to natively compile, but you will see that all the links, including the OpenID configuration, is provided via the well-known link. The well-known links are something from the configuration directly. And if we start when we start next time the authorization server, hopefully natively, you will see that we have also an URL for the key set. So the authorization server itself exposes the entire set of only the public parts of the key. The resource server calls this endpoint, gets all the keys, and identifies the right one using the key ID in the header of the token. So that's how the resource server knows which public key to use. Is it clear, hopefully? Cool. Thank you very much for the question. Do we have any other questions? Yes, we have a question there in the second row. And we have a build success? Yes?
So we saw the... Is it working?
It's working.
So you showed the access token and the ID token. Do we have the chance to generate the refresh token as well?
Yes, of course we have. To do that, you would only have to configure the refresh token on your client. So see, on my client, to make a minimal configuration, I have only added the authorization code grant type, but I could have added as many as I want. So I can just say here, authorization grant type as a second line, and then refresh token. And if I do that, if I now restart the application, generate again, it will generate the refresh token, and I will be able to use the refresh token also.
And the revocation and rotation of the refresh token is also supported?
Sorry?
The revocation of the refresh token and the rotation, is that
the
supported?
rotation of the refresh token, yes, it's implemented out of the box. And you can make it expire or not from the configuration itself. Now, of course, I didn't show you everything because I feel that in maybe 10 minutes I will be kicked off the stage. But the idea is that you have something like token settings here that you can use to configure anything related to the token. And you have also something called client settings here that you would use if you want to configure anything about the client, anything else about the client. So that's how it works. Thank you very much. Other questions?
Can you configure everything to work with two-factor authentication?
Can I configure everything to work with multiple factor authentication? Do you have a scenario in mind?
So let's say that you granted the authority, but the access to your system, but the same system needs to be sent to a third-party library to
understand your question.
To send another key.
So I have used here the form login, which is, well, basic, of course. It just spins up a form so I can use. But like in any other Spring Security application, you can configure your authentication and even create a custom one. So not out of the box, but like in any other Spring Security application, you would be able to do that by implementing a custom authentication method. That's how should it work. Okay? A lot of questions, thank you. Other questions do we have? Or do you just want to see if it's running natively? So we managed to get, not this one. This is ours. We managed to get a build success. It took 1.5 minutes for everything to compile natively. So it's a long time, isn't it? But that's the pitfall. Long compilation, very fast startup. And theoretically, I should be able to say target, and then what was the name? VC something? Pew. Why so long time? 1.3 seconds? I was expecting something more like 0. seconds. It started okay still, so it's not an app problem. It's still a fast time. It's still faster than the previous. It was 2.8, but maybe it's also related to my computer. But it's still faster. We have seen it's faster. Now, if I'm going to Postman to completely answer the question from there, if I call this, it asks for strange one. HTTP OpenID configuration. Okay, fine. I'm not sure why it asks for authentication. It shouldn't. But the idea is that it. Fine. I'm not sure why. Oh, something here. Okay, nobody saw anything. I will investigate it later. Cool. Probably it's related to the native compilation or something. And yeah, I'm not an expert yet in native compilation because it didn't appear officially yet. It will in November, but hopefully at some point I will be. We can try to start it this way if you want, and we can check if that's the case. And then, if you don't have any other questions, we can, yeah, it works this way. So it was related to the native compilation. Okay, we can see here it is the whole OpenID configuration, and somewhere here, this is the endpoint for the key set. So this is the key set. I know it's small, but you will trust me that this is the key set containing our one and only public keys. To, again, completely answer the question from that row. Any other question, or we can dive into randomly giving a few books to some of you guys. Question there.
My question is related to the native compile. Have you used it before?
No, because up to now it's actually experimental. So starting with Spring Boot 3 is the first version where this native compilation will become production ready. So that's why I said I'm not an expert in that yet. I will tell you maybe more next year at VDCLUJ when we meet next time. So
I read a little bit about this, and it seems that it is faster, but it has a lot of problems currently. So that's why I was interested to see if you have any experience.
I wouldn't call them problems. I have the same theoretical experience that you could have with experimenting with the experimental version. That's what we have available. So I'm pretty sure no one here used native compilation yet, at least not with the Spring dependency in production. Did anyone? No, because it's experimental, so you shouldn't. But it has pitfalls, of course. It's not problems, it's downsides. Yeah. Like anything else in software, you have pros and cons, and you have to take the right architectural choice when you decide using or not native. Compilation time is one of it. The fact that you have to be very careful with all the classes, use it through reflection, all the mappers in case you use something like that. These are things that make the compilation of natively compilation of a Spring app difficult. But if you manage to do that, then what you get is an executable that spins up much faster than a non-native compilation. That's how it works.
Okay.
Okay.
Thank you.
Another question we have there. No, please use the microphone. And I think it should be the last one, because then I will have to make the extraction. And if you have other questions, guys, no worries. You will find me the rest of the day. You will find me tomorrow morning as well. And if you don't find me the rest of the day and tomorrow morning, you can find me on LinkedIn, Twitter, YouTube, and you can ask me the questions. Yes, please.
My question would be, how easy would it be to delegate to another identity provider?
Oh, that's a federation.
Yeah.
That's a very good question, actually. I can't prove it now because I only have one more minute. I promise I will make an example, a practical example on that for one of the later events. But to answer you, this is possible, and you can use for the federation. And if I'm not wrong, in the documentation, the documentation of this project is very in the early phases, but there are some examples there already, and I think one of them is proving how to do that. You just have to go on the official GitHub page that I was sharing on one of the slides earlier. Thank you also. Cool, guys, with that being said, let's extract some names. I need 5 of you. First 3 will get one of the copies. If you want a signature, I will give you a signature. The last 2 will get 2 ebooks. So, should we start? Is anyone here who didn't have the chance to register and wants to do that? So I can show the QR code again. No, everyone is here. Okay, fine. Okay, let's do like this. And we have long list, 49 people. 48 actually, because the first one is me. So starting with 3 and up to 49, going here, 3 to 49, okay? And we have number 34, Alina. Ah, so happy. Number 13. 13 is a lucky number today. Adela. Number 9. Ioana. And we have 2 ebooks, 2 more ebooks, okay? 7. I will have to learn how to pronounce your name later, if you help me. And then the last, 26. Andrei. And these are the ebooks. Cool. So guys, that was everything. Thank you very much for your presence. Thank you very much for the questions. If you still have them, please find me outside. Otherwise, I wish you a pleasant continuation of your conference. And for those of you who are traveling, safe travels home. Bye.